take a look at this problem. We got 4x plus y equals negative 17. And we got 6x plus 2y equals negative 26. Instructions say write each equation in slope-intercept form and graph it. Then indicate whether the system has one solution, no solution, or infinite number of solutions. Okay. So we want to solve for y. This first one's pretty easy. Let's take the 4x, move it to the right side. Then we got y is equal to negative 4x minus 17. On this one, we want to get y by itself. So I'll take the 6x and move it over. And we got 2y is equal to negative 6x minus 26. And then we'll divide everything by 2 because we want to get y by itself. And so we get y is equal to negative 3x minus 13. Now for this one, the y-intercept is negative 17, the number at the end. For this one, the slope, number in front of your x, which is negative 4, and I'll put it as a fraction, negative 4 over 1. Now for this one, our y-intercept is negative 13, and our slope is negative 3 over 1. Again, slope is whatever's in front of your x, I'll put it in fraction form. This might be a little tricky. Negative 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so y-intercept is down here. Now from there, we're going to use our slope to get the next point. Negative 4 over 1, that means go down 4, right 1. Negative up on top means down, and a positive down below means right. So I got 1, 2, 3, 4. So I go down 4, right 1. And that's where I put my second point. And then draw a line between them as well as I can. Okay. Now our y-intercept, negative 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that says we're going to go down 3, right 1. So down 3, 3, right 1. Should be right there. As good as I'm going to draw a straight line. Let's see. 1, 2, 3, 4, 5, 6, 7. My guess would be negative 7, 0. Now, if you're roughly close to that on your answer, then I'm going to give you a full points for that. What you're going to find is that this isn't a very precise method when you're dealing with, especially when it's way down there. When it's fairly close to the origin, then it's not bad. Well, let's take a look at it with another method. Let's take a look at the addition method. So we got 4x plus y is equal to negative 17. Is it asking us to find the answer? Yeah, it is asking us to find the answer, isn't it? They only include a 10 there. That's nice. Okay, so 4x plus y is equal to negative 17. We got 6x plus 2y is equal to negative 26. Now we want to eliminate one of our variables. I'll eliminate the y. So I'll multiply my first equation by negative 2. And that'll get rid of the y's once I add them. Negative 2 times 4x gives me a negative 8x. Negative 2 times y is negative 2y. Negative 2 times negative 17 is 34. And then I got 6x plus 2y is equal to negative 26. Negative 8x plus 6x is negative 2x. Negative 2y plus 2y cancels. 34 minus 26 is 8. Then divide both sides by negative 2. And we get x is equal to negative 4. Obviously my graphing skills are not that great. I can't draw a straight line. Okay. Well then, we're going to take that negative 4 and plug it back into one of our equations. I'll pick the first one. So we got 4x plus y is equal to negative 17. We just said that x is negative 4. So I got 4 times negative 4 plus y is equal to negative 17. So we got negative 16 plus y is equal to negative 17. Take the negative 16 over. It becomes a positive 16. And we end up with y is equal to negative 1. So our answer will be negative 4, negative 1. Geez, I wasn't too close, was I? I said negative 7, 0. But that's what we come up with. Well, let's take a look at how to do it one last way. Do it on the calculator. Now, here's my system of equations I'm working with. So I'm going to come up the matrix that goes along with that. So we got 4, 1, negative 17, 6, 2, negative 26. Remember, get all of your terms with variables on one side, numbers on the other, and then you drop your variables in equals and keep the numbers in their signs. Okay, so that's going to be a 2 by 3. Remember the size is rows by columns. So I'm going to go and do a second x to negative 1, go to my matrix. If you have a TA3, you may have a matrix button. Go over to edit, enter on A, and then 2 by 3. Then type in each number, pressing enter after each one. So 4, enter, 1, enter. Negative 17, enter. 6, enter. 2, enter. Negative 26, enter. I'll do a second mode to exit out. Go back to my matrix menu, second x negative 1. Right arrow to math. Up arrow to RREF. Make sure you choose the one with 2 R's. Press enter. And I go back to my matrix menu, do enter on A, and enter again. And we come up with negative 4, negative 1. Now the question is whether it worked or not, and it did. Remember, with a 2 by 2 equations, 2 variables, our first 2 by 2 square should be a diagonal 1, 0, 0 else. That means it worked. If it worked, these are our answers. This is x, and this is y. The order of your answers matches the order of your columns. I put x values here, and I put y values here. If I had switched these around, put the y's here and x's here, then this would have been y and this would have been x. And so we get the same answer as this right here. Obviously, you can see finding a solution by graphing is not that good of a technique unless you have graphing paper. So if you do use that technique and it specifies that on the test, I'm going to be very forgiving, just as long as your graph looks roughly what it should be. If you just can't draw a straight line, I'm not going to penalize you for that. Okay, let's take a look at this second one. It says write each equation in slope-intercept form and graph each equation. Same idea, and find our answers. So we got 2x plus 2y equals negative 30, and 3x plus 3y is equal to negative 45. Okay, I want to solve for y. So I'm going to take this 2x and move it over. Then we get 2y is equal to negative 2x minus 30. I'll divide everything by 2. And we got y is equal to negative x minus 15. Another one that's way down there. Okay, this one I'm going to solve for y. So I'll take the 3x and move it over. So we got 3y is equal to negative 3x minus 45. Divide everything by 3. And we got y is equal to negative x minus 15. Same line. Interesting. Since it's the same line, then we don't really need to graph it, because one of our solutions is infinite number of solutions. Intersects everywhere. So, infinite number of solutions. Now, if I were to solve these by adding or elimination, we got 2x plus 2y is equal to negative 30. And we got 3x plus 3y is equal to negative 45. And let's say I'm going to eliminate the y's. I'm going to multiply this first equation by 3, and I'll multiply the second equation by negative 2. Sometimes you have to multiply both equations by a number. So that gives us 6x plus 6y is equal to negative 90. This one would give us negative 6x minus 6y is equal to positive 90. 6x minus 6x drops away. 6y minus 6y drops away and gives us 0. Negative 90 plus 90 drops away and gives us 0. So we end up with 0 is equal to 0. When your variables disappear and you end up with 0 is equal to 0, that means the same thing. It's an infinite number of solutions. It means it's the same line. Now do it on the calculator. Now here's our set of equations we're working with again. So I'll drop the x's, drop the y's, and equals. Keep the numbers in their signs. So I got 2, 2, negative 30, and I got 3, 3, negative 45. So let's go ahead and put this in. So I got second x negative 1. Go over to edit. Enter on A. 2 by 3. So do 2 enter, 3 enter. Or you can just simply press enter on those numbers. 2 enter, 2 enter, negative 30, enter. 3 enter, 3 enter, negative 45, enter. Okay, now I do a second mode to exit out. Then I'll do my second x negative 1. Go over to math. And I'll choose RREF, so I'll up arrow over and over until I get to it. Press enter on it. Go back to my matrix menu. Do enter on A. Enter again. And we get 1, 1, negative 15, and 0, 0, 0. Now, how you can tell if it worked is if you got two equations, two variables, 2 by 2, your first 2 by 2 square should be a diagonal 1, 0, 0 else, which it isn't. So it didn't work. Specifically, notice that your last row is all zeros. Last row is all zeros means you got an infinite number of solutions. So all three methods give you the same result on that one. Let me save this. And trying to find pages here. There it goes. Okay, so this is a form. This is test 4. This will be page 1. obviously not. Yeah, let me just call it systems equations. IAWR sys of equations. Page 1. Okay, let's start a new page then. And let's take a look at this one. Negative 4x plus y equals 12, and negative 8x plus 2y is equal to 14. What are they asking here? Okay, that's, I was looking down here, but that's for problem number 4. Okay, so same instructions. Well, we haven't had much luck so far with the graphing, but we'll see. I mean, and one that shows the answer very clearly. So let's try to solve it by graphing. We'll solve each one for y, slope-intercept form. See where that heads. This one, bring negative 4x to the right side, so we got y is equal to a positive 4x plus 12. That's way up there. This one, I want to solve for y, so I take negative 2x over. So we got 2y is equal to 8x plus 14. Divide everything by 2. And we get y is equal to 4x plus 7. Okay, so this one, its y-intercept is 12. And the slope is 4. And I'll put that in fraction form, that'll be 4 over 1. Now this one, our y-intercept is 7. And our slope is 4. Now since they have the same slope, that means they're parallel lines. And since they have different y-intercepts, that means that they're never going to intersect. So if I graph it, that'd be fine, but I'm going to see that. So they're parallel lines, which means there's no solution. Let's see if that's how they write it. No solution. Okay. Now if I was doing this by addition or elimination method, we got negative 4x plus y is equal to 12. Negative 8x plus 2y is equal to 14. I'm going to eliminate the y's, so I'll multiply this first equation by negative 2. Negative 2 times negative 4x gives us a positive 8x. Negative 2 times y is negative 2y. Negative 2 times 12 is negative 24. And I got negative 8x plus 2y is equal to 14. 8x minus 8x drops away. Negative 2y plus 2y is 0. Negative 24 plus 14 is negative 10. Now our variables disappeared again. We don't have any variable left. And we come up with something that can't be. 0 is equal to negative 10. When you come up with something that can't be, then it's no solution. The other case, remember our previous problem, is you come up with 0 is equal to 0, which is true all the time, which means that you got infinite solutions. Okay, on the calculator. Working with this system equations, I'll drop the variables, keep the numbers in their signs. Still a 2 by 3. Everything in this section is a 2 by 3. So I'll go and put it in. I'll do second x negative 1. Go over to edit, enter on A, 2 enter, 3 enter. And I got negative 4, 1, 12. Negative 8, 2, and 14. Now let's do a second mode to exit out. And then I'm going to do, go to matrix, right arrow to math, up arrow to RREF, press enter. Go back in my matrix menu, enter on A, enter again. Now I got a decimal. We don't want decimals, so I'll do math, enter, get rid of it. And we're going to have 0, negative 1/4, 0, 0, 0, 1. Again, two equations, two variables. Your first 2 by 2 square should be a diagonal of 1, 0, 0 else. It isn't, so it failed. Last row is all zeros and a single 1. That indicates to us no solution. It'll always be all zeros and a single 1. Let me grab a drink here. And let's go to problem number 4. Determine if the given ordered pair lies in both the lines in system equation by substituting a point into. Where's system equations? Oh, it's right there. I'm blind. Okay, 4x plus 3y equals 3, and negative 8x minus 6y is equal to negative 6. Then we're wondering about 3, negative 3. And the other one they're asking us about is 0, 1. Well, they're giving us a point. So they're giving us the x and the y. Okay, we're going to plug it in our first equation. So we've got 4x plus 3y is equal to 3. And we said that x is 3, and we said y is negative 3. So I put parentheses wherever our variables were, and then I'd plug in the numbers. And this is more of a question mark at this point. We're wondering if that's equal. Well, 4 times 3 is 12 minus 9. We're wondering if that's equal to 3. 12 minus 9 is 3, so we end up with 3 is equal to 3. So that one checks on that one. We also need to plug it into the other one. So I got negative 8x minus 6y is equal to negative 6. And we're going to put parentheses where our variables were before we plug in our numbers. Again, we said x was 3. We said y is negative 3. And this is more of a question mark at this point. So I got negative 24 plus 18 is equal to negative 6. Negative 24 plus 18 is negative 6 equals negative 6. So that checks. So the answer to our first part here is yes. That does fall on both those lines, and that's the solution. It says determine if the given order pair lies on this by substituting. When they say it lies on both of the lines, since lies on both of the lines, that would be where it intersects. Now, if I plug in 0, 1, now just because it works here doesn't mean it won't work here, because our solution could be an infinite set of solutions. So it could work for infinite number of points. Okay, so do the same thing. We got 4x plus 3y is equal to 3. Where x was, we'll put in parentheses. And we said this is x and this is y. So I'll put 0 in for the x, and I'll put 1 in for the y. And this is, again, a question mark at this point. We're wondering if that's true. 4 times 0 is 0. 3 times 1 is 3. So we get 3 is equal to 3. So that checks. Well, let's try it on the other equation. So I got negative 8x minus 6y is equal to negative 6. We'll go through and replace our variables with sets of parentheses. Again, we said x was 0. We said y is 1. And this is a question mark at this point. Negative 8 times 0 drops away. Negative 6 times 1 is negative 6. And we get negative 6 equals negative 6, which checks. So the answer to this one is yes. And if we think about it, take a look at the first equation. If you multiply everything by negative 2, negative 2 times 4x gives you negative 8x. Negative 2 times 3y gives you negative 6y. Negative 2 times 3 gives you negative 6. These are the same lines, aren't they? So there is an infinite number of solutions you could plug in. Okay, number 5. Sum of two numbers 40, and their difference is negative 50. What are the two numbers? Let x equals one number and y is equal to the other number. Corresponding modeling system is x plus y is equal to 40, and x plus y is equal to negative 50. It says solve the system graphically. Like, we've had a lot of luck in that area. Okay. X plus y is equal to 40. X minus y is equal to negative 50. Oh, it's such perfect form for the addition method, but which I'll show here in a minute. Okay, so to graph these, then there's different ways you can do this. The since it doesn't tell us to, oh, it does say solve for y. I'd probably say the finding the x-intercept and y-intercept is the easiest way. But since they say solve for y, x plus y is equal to 40, and then take the x over, so I got y is equal to negative x plus 40. And on this one, I want to solve for y, so I take negative y over to the right side. I'm going to take negative 50 to the left side. So we're going to get x plus 50 is equal to y. Okay, and this first one, our y-intercept is 40. And our slope is negative 1. And I'll put it in fraction form, negative 1 over 1. On this one, our y-intercept is 50. And our slope is a positive 1, the number in front of your x. And I'll put it in fraction form, 1 over 1. Okay, let's see how this goes now. They're giving us this right here. I guess they go out a little bit this way. Y-intercept is 40 and 50. Okay, that's 10. That's 20, 30, 40, and 50. Okay, so come up here to 40, and then it's up or down 1. The negative 1 means down 1 and right 1. Down 1, right 1. Closest I get is probably right there. So if I graph it, looks like that. Y-intercept is 50 is right here. And then I'll go up 1, right 1, up 1, right 1. Be like right there. And then if I draw that, my best guesstimate would be negative 5, 45. Let's see how close I am. Okay, let's use the addition method. The way that I said is probably best to begin with. X plus y is equal to 40. By the way, since these numbers are so large, getting an accurate picture of a slope that's so small skews it. It's almost like they're picking problems to show why you shouldn't use the graphing method. Okay, x plus x is 2x. Y minus y drops away. 40 minus 50 is, negative 10. Is that actually, I don't know about the 45. We'll see. Then we'll divide both sides by 2. And we get x is equal to negative 5. Now we're going to plug that back into one of our equations. I'll pick the first one. So I got x plus y is equal to 40. X is negative 5. So plug the negative 5 in for the x and solve for y. So I got y is equal to 40 plus 5, or y is equal to 45. So we end up with negative 5, 45. Guess I should have finished the problem before I ran my mouth. That method actually was halfway decent. Now, this didn't actually look like 45 to me. It looked more like 46, 47. But I figured that my graphing was poor, so I figured I adjust it accordingly. Okay, now let's do it on the calculator. So we're going to have 1, 1, 40, and 1, negative 1, negative 50. Again, all of your terms with variables have to be on one side, numbers on the other. You drop the variables and equals, keep the numbers in their signs. Keep in mind, if there's not a number in front of the variable, there's a 1 there. Okay. So let's go ahead and put this in. We'll do second, x to negative 1. Go over to edit, do enter on A. It's a 2 by 3. I already have 2 and 3 there, so I'll just press enter on. I got 1, 1, 40. And I got 1, negative 1, negative 50. Exit out, second mode. Then I'll go back in my matrix menu, second x to negative 1. Right arrow to math, up arrow to RAF. Press enter on it. Go back in my matrix menu, enter on A, enter again. So that gives us 1, 0, negative 5, 0, 1, 45. Well, 2 equations, 2 variables. Your first 2 by 2 should be a diagonal 1, 0, everywhere else it is. It means it worked. This will be x, and this will be y. So we get the same answer. Negative 5, 45. Let me go ahead and save that page. And start a new one. And we'll take a look at problem number 6. Perimeter of rectangle is 170 meters and length is 15 meters longer in width. Find dimensions of the rectangle. Let x equals the length and y is equal to width. Corresponding modeling system is 2x plus 2y equals 170. X minus y is equal to 15. Looks like they're again indicating they want us to solve it graphically. So let's try that. See how we do. Now we want to solve each one of these for y. Okay, so this one I'm going to take 2x over. So we got 2y is equal to negative 2x plus 170. Divide everything by 2 to get to y by itself. And we will end up with y is equal to negative x plus 85. Now in this one, I want to get y by itself, so I can take the negative y over to this side and the 15 over to this side. So we got x minus 15 is equal to y. Okay, graphically. This one, the y-intercept is 85. Okay, so here's 10. Here's 20. 30, 40, 50, 60, 70, 80, 85. Okay, so it'll be right there. Now the number that's in front of our x is a negative 1. So slope is negative 1 over 1. So we'll go down 1, right 1. Be about right there. And it would look something like that. Okay, this one's negative 15. Okay, there's negative 10, there's that, so it'll be about right here. And the number in front of our x is a positive 1, which means slope is 1, or you put in fraction form 1 over 1. Means we'll go up 1, right 1. And that wasn't a very straight line, but we'll pretend it is. Okay. So that'd be 10, 20, 30, 40. So I'd say x is 35. Y would be, almost looks like 28, 29, but let me guess 30. Okay. Let's see how close I was. Let's use the addition method. So I got 2x plus 2y is equal to 170. X minus y is equal to 15. I'm going to multiply the second equation by 2. So I'm going to get 4x plus 4y equals 300. Okay, let's try that again. First equation I'll leave alone. So I got 2x plus 2y is equal to 170. Multiply the second equation by 2. So we got 2x minus 2y is equal to 30. Add those together. 2x plus 2x is 4x. 2y minus 2y drops away. 170 plus 30 is 200. Divide both sides by 4. And we get x is equal to 50. Okay. Wasn't very good on that one. Now we're going to plug that back into one of our equations. Second one looks a little easier. So I got x minus y is equal to 15. We just said x is 50. So I got 15 minus y is equal to 15. I want to solve for y. So I take negative y over here, take 15 over there. So we got 50 minus 15 is equal to y. Or y is equal to 35. So we'd have 50 and 35. Now a lot of times you can check it by seeing if it makes sense with the problem. 50 and 35. Perimeter is 170, a rectangle. Well, yeah, that'd work. Assuming this is the width and this is length, so I'd have to look see which is which. But anyway, the perimeter adds up to 170, so that's a plus. Length is 15 meters longer than the width. Yeah, this is 35 plus 15 gives you 50, so that checks. Okay, let's do it on the calculator. Drop the x's, the y's, and equals. Keep the numbers in their signs. And let's go ahead and put this in. Okay, so I'm going to do second x negative 1. Go on the matrix menu. Go over to edit. Do enter on A. Enter on 2. Enter on the 3. And I got 2, 2, 170. 1, negative 1, and 15. Then I'll exit out. Go back in the matrix menu, second x negative 1, right arrow to math, up arrow to RREF. Press enter. Go back in the matrix menu, do enter on A, enter again. And we'll get 50 and 35. Now it worked. Two equations, two variables. Your first 2 by 2 should be a diagonal 1, there's everywhere else, and it is. That means this is my x, and this is my y. So our answer would be 50, 35. Okay, let's take a look at problem number 7. Determine a solution of the system equation represented by lines in a graph. Check your solution by substituting into both equations. Okay, now looking where these intersect, it looks like 1, 2, 3, 1. So our answer would be 3, 1. Now what they mean by checking your solution by substituting into both equations, we got 2x plus 3y equals 9. And we got 5x minus 5y is equal to 10. When they give us a point, they're giving us the x and they're giving us the y. So we're going to go through and replace our variables with parentheses. And we just said that x is 3, so I'll put 3 in for the x. We said y is 1, so I'll put 1 in for the y. And this is a question mark. We're wondering if that's equal. 2 times 3 is 6, plus 3 times 1 is 3. Wondering if that's equal to 9. And 6 plus 3 is 9, so 9 is equal to 9, so that one checks. We'll do the same thing on this other one. Go through, replace your variables with parentheses. We just said x is 3 and y is 1, and this is a question mark. 5 times 3 is 15, minus 5, wondering if that's equal to 10. And 15 minus 5 is 10, so we get 10 is equal to 10. So that checks. So our answer is 3, 1. Okay, I'll grab a drink here. Number 8. Negative 5x plus y equals negative 12. And negative 10x plus 5y is equal to negative 15. And it says solve it by the substitution method. Substitution method. Step 1. You solve one of the equations for one of the variables. I'm going to pick the first equation. I got negative 5x plus y is equal to negative 12. Easiest one to solve for here is y. So I take the negative 5x over, it becomes a positive 5x. So we get y is equal to 5x minus 12. Step 2, plug this into the other equation. So our other equation is negative 10x plus 5y is equal to negative 15. Now we just said that y is equal to 5x minus 12. So we want to replace the y in the other equation with 5x minus 12. So I put parentheses where my y was, and then I put in the 5x minus 12. And then we want to solve. Distributive property, 5 times 5 gives us 25x. 5 times negative 12 is negative 60. Negative 10x plus 25x is 15x. Minus 60 equals negative 15. Take the negative 60 over, it becomes a positive 60. Negative 15 plus 60 is 45, I think. Then divide both sides by a number in front of your x, which is 15. And you get x is equal to 3. Step 3. Plug this into the equation from step 1. It's always solved for the other variable. So we got y is equal to 5x minus 12. We just said x is 3. So we got 5 times 3 minus 12. 5 times 3 is 15 minus 12. Y is equal to 3. So our answer would be 3, 3. Now you could check that by plugging it back into the system equations up here. I'm going to show it on a calculator. So I'm going to drop my x's, y's, and equals, keep the numbers in their signs. So I got negative 5, 1, negative 12. Excuse me. And I got negative 12, 5, and negative 15. Okay, so I'm going to do a second x negative 1. Go over to edit. Enter on A. It's 2 by 3. We got negative 5, 1, negative 12. And we got negative 10, 5, and negative 15. Exit out, so I do second mode. And now go through and do my REF. So do second, x negative 1, right arrow to math, up arrow to REF, enter. Go back in the matrix menu, enter on A, enter again. Okay, so that's what we come up with. 2 equations, 2 variables. Our first 2 by 2 should be a diagonal 1, 0, 0, else, which it is, which means it worked. This is x and this is y. So we get the same answer, 3, 3. Calculator is excellent, even if you're doing it by hand, just to check your work. Let me save that. And start a new page. Okay, something's wrong. I got off on my numbering, I guess. I think I've worked every problem. Oh well, if I've missed some, then you've seen other examples. But this should be number 9, I guess. Just out of curiosity. Six, 7, 8. Okay, it is number 9. Okay. I didn't get off. I just didn't realize I was looking at the wrong numbering. Of course, now I close the review down. That's great. Here it is. I apologize for me clearing my throat. Taking a drink doesn't seem like it's helping. Okay, number 9. Let me grab another drink, see if it helps a bit. Number 9. 6x plus 6y equals negative 30. And we got 3x plus 3y is equal to negative 15. And it says solve it by substitution. If you notice that they are all divisible by the same number, you can go ahead and divide them. Like all the numbers in the first equation are divisible by 6, and all the ones in the second equation are divisible by 3. I'm not going to do that, but if you see it, that will save you a little bit. Okay, solve one of the equations for one of the variables. So I'll pick the second one. So we got 3x plus 3y is equal to negative 15. And I want to solve for y. So I'll take 3x over. So we got 3y is equal to negative 3x minus 15. And divide everything by 3. And we get y is equal to negative x minus 5. Step 2, plug this into the other equation. So I got 6x plus 6y is equal to negative 30. And we just said y is equal to this. So we're going to replace the y here with a set of parentheses. So we got 6x plus 6 times and we just said the y up here is negative x minus 5. So we're going to place the y here with negative x minus 5. And then equals negative 30. And then we want to solve. Well, 6 times negative x is negative 6x. 6 times negative 5 is negative 30. 6x minus 6x drops away. We get negative 30 is equal to negative 30. Okay. Well, this is a problem. We are solving for x and y, and our variables disappear completely. But look what we came up with. We came with something that's always true. Negative 30 is equal to negative 30. This means that there's an infinite number of solutions. So infinite solutions. And specifically, for the instructions here, that means they're dependent. Okay, now if I was doing it on a calculator, put in the numbers, drop in the x's, y's, and equals, keep the numbers in their signs, would have this 2 by 3 matrix. So let's go ahead and put that in. Do second x negative 1, go over to edit, enter on A, 2 by 3, rows by columns. Then we got 6, 6, negative 30, 3, 3, negative 15. Exit out, do a second mode, and then I'll do my second x negative 1, go over to math, and up arrow to RREF, enter on that. Go back in the matrix menu, enter on A, enter again. And that gives us 1, 1, negative 5, and 0, 0, 0. 2 equations, 2 variables. Our first 2 by 2 should be a diagonal 1, 0, 0 else. It isn't, so it didn't work. Last row is all zeros, which again means infinite solutions, which is a dependent system of equations. Okay, number 10. Solve the following system of linear equations by substitution. We've got 4x plus 2y is equal to negative 20. And 4x plus 2y is equal to 8. Well, warning bell should be going off right there anyway. But see how we have 4x's match and 2y's match? We're going to see something happens there. But anyway, let's go through our steps. Because they're again asking us to do it by substitution. So our first step, solve one of the variables for one of the equations. Or solve one of the equations for one of the variables. Second equation, we got 4x plus 2y is equal to 8. And we'll solve for y. So take 4x over, we get 2y is equal to negative 4x plus 8. Divide everything by 2. And we got y is equal to negative 2x plus 4. Step 2, plug this into the other equation and solve. So we got 4x plus 2y is equal to negative 20. Now, right up here we said y is equal to negative 2x plus 4. So we're going to replace the y here with negative 2x plus 4. So first thing I'll do is go through and put parentheses in for the y. And again, we said y was this, so we're going to plug that in. So we got negative 2x plus 4. Well, 2 times negative 2x is negative 4x. 2 times 4 is 8. 4x minus 4x drops away, and we got 8 is equal to negative 20. Got a problem again. Our x's and y's disappeared, and all we got is numbers. And specifically, we got something that can't be true. 8 is equal to negative 20. Now this is our inconsistent. This means no solution. But they're asking whether it's inconsistent or not. So we say no solution, inconsistent. So make spell right. Okay, that looks right. Now let's plug this in the calculator and see what we get. So I got 4, 2, negative 20, 4, 2, and 8. It's a 2 by 3, rows by columns again. So go to our calculator. We'll do second x to negative 1. Go over to edit, enter on A. 2 by 3, so do 2 enter, 3 enter. And we got 4, 2, negative 20. And then we got 4, 2, and 8. Now I'm going to exit out, so I do a second mode. Now I'll go back to the matrix menu, second x to negative 1. Go over to math, right arrow to math, up arrow to RREF. Press enter on it. Go back in my matrix menu, second x to negative 1. Enter on A, enter again. Now we get decimals, we don't want decimals ever. So we do math, enter, enter. At least we don't want decimals on matrices. So we got 1, 1/2, 0, 0, 0, 1. Two equations, two variables. Our first 2 by 2 should be a diagonal of 1, 0, 0 else. It isn't. It means it didn't work. And specifically, this oddball case is where you got all zeros and a single 1 on your last row. That means no solution, which also means inconsistent. Okay. Problem number 11. So solve the following system of equations by substitution. How many substitutions are there? I guess I really haven't looked at the review. 30 problems still. Okay. Not even halfway through. So 7x plus y is equal to negative 21. 4x minus y is equal to negative 1. Okay. To solve for by substitution, you solve one of the equations for one of the variables. Let me pick the first one. So we got 7x plus y is equal to negative 21. And I'll solve for y. So I'll take 7x over. We got y is equal to negative 7x minus 21. Now we want to plug that into our other equation. So our other equation is 4x minus y equals negative 1. And let me try it again. 4x minus y is equal to negative 1. Now up here, we said y is equal to negative 7x minus 21. So we're going to replace just the y in the other equation with negative 7x minus 21. Everything else remains exactly the same. The 4x, the minus, and negative 1. Well, remember, a negative out in front of your parentheses flips the sign of everything inside, so this negative 7x becomes a positive 7x. This negative 21 becomes a positive 21. Combine like terms. 4x plus 7x is 11x plus 21 equals negative 1. Take the 21 over to the right side, becomes a negative 21, which then gives us negative 22. Divide both sides by a number in front of your x, which is 11. And you get x is equal to negative 2. Step 3. Plug this into the equation from step 1. It'll always be solved for the other variable. So we got y is equal to negative 7x minus 21, and we just said x is negative 2. So we're going to replace the x with negative 2. So negative 7 times negative 2 is 14. And 14 minus 21 gives us negative 7. So our answer will be negative 2, negative 7. Now let's do this on the calculator. Now it's already in perfect form. All the terms of the variables are on one side, numbers on the other. So I'll drop the variables and the equals, keep the numbers in their signs. So we got 7, 1, negative 21, 4, negative 1, and negative 1. Okay, the size of our matrix is 2 by 3. So I do second x negative 1. Go over to Edit, enter on A. It's a 2 by 3, so I do 2 inner, 3 inner. And we got 7 inner, 1 inner, negative 21, 4, negative 1, negative 1. And then I'll exit out, second mode, go back in the matrix menu, second x negative 1, right arrow to math, up arrow to RREF. Enter on it. Then second x negative 1, enter on A, enter again. And we end up with negative 2, negative 7. Again, 2 equations, 2 variables. First 2 by 2 should be a diagonal 1, 0, 0 else. It is. So this is x and this is y. And we come up with the same answer, 2, negative 7. Problem number 12. Decimals, yuck. Okay, negative 1.2x plus 0.2y equals negative 6.5. 3.6x minus 0.6y equals 23.5. Now, I just like decimals, so I'm going to get rid of them. And how you can do that is you move all of them the same number of decimal places to the right. So, like on the first equation, I'll move all of them to the right one place. So it becomes negative 12x plus 2y equals negative 65. Our second one becomes, I'll move all those one place to the right. That becomes 36x minus 6y equals 235. Numbers become a little larger, but you don't have to work with decimals then. Okay, substitution. Solve one of the equations for one of the variables. Pick the first one. So I got negative 12x plus 2y is equal to negative 65. I'm going to solve it for y. So I take negative 12x to the right side. So we got 2y is equal to 12x minus 65. Divide everything by the number in front of your y, which is 2. And we get y is equal to 6x minus. Question is, do I want to work with a fraction or do I want to work with decimals? I'll work with fractions. So minus 65 over 2. Step 2. By the way, if you like decimals, you could work these with decimals. It doesn't matter. Step 2 is plug this into the other equation. Okay, so we were working with this first one, so we'll plug in the second one. So we got 36x minus 6y is equal to 235. So we got 36x minus 6 times. Now, up here we said y is equal to 6x minus 65 over 2. So we're going to replace just the y in the other equation with 6x minus 65 over 2. Well, solve this now. So distributive property. Negative 6 times 6 gives us negative 36x. Okay. Negative 6 times negative 65 over 2. Negative times negative is positive. And 6 divided by 2 is 3 times that gives us 195? Let me check. 195. Okay. It goes 235. Well, 36x minus 36x drops away. And so we end up with 195 equals 235. Which means there's no solution. Which means they're inconsistent, but let's see what they're asking for. Okay, inconsistent. So these are inconsistent. whenever you come up with something that can't be, 5 equals 2, 7 is equal to 8, something like that, then that means no solution, inconsistent. Now if I did this on the calculator doesn't care that there's decimals, so I'll put in negative 1.2, 0.2, negative 6.5, 3.6, negative 0.6, and 23.5. Okay, so go to my matrix menu, second x negative 1. I'm going to left arrow over to edit and do enter on A. It's a 2 by 3 again, so I do 2 enter, 3 enter. I know it already has those numbers, but if you fast forwarded, and you may not have those numbers if that's your first problem you're taking a look at. So I got negative 1.2, enter, 0.2, enter, negative 6.5, enter, 3.6, enter, negative 0.6, enter, and 23.5, enter. Then I exit out, so I do second mode, go back in my matrix menu, do second x negative 1, right arrow to math, up arrow to RREF, press enter on it. Go back in my matrix menu, second x negative 1, enter on A, enter again. Got decimals. We do not want decimals at all. Notice that there's 3 dots here. It means there's more to the right. If you press your right arrow key, you can see that. And then there you see the dots are over here, so you press your left arrow key to go back. Not that that matters. We don't want decimals. So we do math, enter, enter. And so we end up with 1, negative 160, 0, 0, 1. Notice our, well, first off, 2 equations, 2 variables. Our first 2 by 2 should be a diagonal 1, zeros everywhere else. It isn't, so it failed. Last row is all zeros and a single 1, which means no solution or it means inconsistent. Let me save this. And start a new page. So problem 13. We've got 3y equals negative 3x plus 21 and 7x equals negative 7y plus 49. Let's see what happens with this. Notice that basically they have the same numbers before the x's and y's if once I get everything over on one side. But let's see what happens. First step. This is solving by substitution. Solve one of the variables for one of the equations. I'll pick the first one. So I got 3y. Solve one of the variables for one of the equations. Yeah, that's right. Or solve one of the equations for one of the variables. I'll wake up here eventually. I can do math just fine, I just can't speak. Okay, and I'm going to divide everything by 3 to get y by itself. So those 3's cancel. Negative 3 divided by 3 is negative 1, or just negative x, plus 21 divided by 3 is 7. Step 2. Plug this into the other equation. Our other equation is 7x equals negative 7y plus 49. Here we just said that y is equal to negative x plus 7. So we're going to replace just the y in the other equation with negative x plus 7. So I got 7x is equal to negative 7 times negative x plus 7 plus 49. Distributive property, negative 7 times negative x is 7x. Negative 7 times 7 is negative 49 plus 49. Combine together like terms, combine together numbers in any step. Negative 49 plus 49 cancels. And we get 7x equals 7x. And we're solving this. This is a linear equation. So get rid of parentheses, we already did. Get rid of fractions, don't have any. Third step, get everything with a variable on one side, numbers on the other. So take that over. So we got 7x minus 7x equals 0. Combine like terms, 7x minus 7x is 0. We end up with 0 is equal to 0. What that means, our variables disappeared, is one of our oddball cases. You come up with something that's always true, 0 is equal to 0. That means that there's an infinite number of solutions, which means they're dependent. Okay, let's look at this on a calculator. First off, on a calculator, you have to have all of your terms with variables on them on one side, numbers on the other. So I'm going to take this negative 3x and move it over, and I'll take this negative 7y and move it over. So I'm going to have 3x plus 3y is equal to 21, and 7x plus 7y is equal to 49. Now notice when I moved them over, I made sure that the x's lined up and the y's lined up in the same column. So rearrange your terms such that that's true. That's the only way that the calculator will work. Now you might get those mixed up in this problem and then put in the calculator in a mixed up order and you think, well, he's wrong. Well, the only reason that you could mix them up here is because they're both the same number. So I got 3, 3, 21, 7, 7, 49. It's a 2 by 3 again. So I'm going to go input this in. I'll do second, x and negative 1. Go over to edit, enter on A. Again, 2 enter, 3 enter. And I got 3, 3, 21. 7, 7, 49. Exit out, do second mode. And now go back in the matrix menu, second x negative 1. Right arrow over to math. Up arrow to REF. Enter. Go back in the matrix menu. Enter on A. Enter again. Now notice here. Well, first off, you have to make sure you do REF. Now you didn't do just REF, one with one R. But our first 2 by 2 should be a diagonal 1, zeros everywhere else. It isn't. This is an oddball case. Specifically, our last row is all zeros. Last row is all zeros means infinite solutions or means dependent. So that's how you do it on the calculator. Number 14. Let me grab a drink before I do this one. All right, the addition method. I like addition method pretty well. Got 4x plus 4y is equal to negative 16. And negative 6x plus 6y is equal to 24. Well, we need to eliminate one of the variables. I might as well eliminate the x's because they're already different signs. It doesn't matter. You could eliminate the y's. Now, I want these numbers to be the same. So I think, what can I multiply times a 4 and times a 6 to get them the same? Well, 12 would be a good number to work with. So I multiply the first equation by 3, and then I'll multiply the second equation by 2. Now you could have went with 24. Your number's a little larger, but it still gets the same answer. Okay, so 3 times 4x is 12x. 3 times 4y is 12y. 3 times negative 16 is negative 48. 2 times negative 6x is negative 12x. 2 times 6y is 12y. 2 times 24 is 48. Add these together. Negative 12x, or 12x minus 12x drops away. 12y plus 12y is 24y. Negative 48 plus 48 is 0. That's interesting. So then divide both sides by 24. and you get y is equal to 0. Now we want to plug that in one of the other equations, or plug it in any equation and solve for the other variable. So I got 4x plus 4y is equal to negative 16. We said the y is 0, so put 0 in for the y. 4 times 0 drops away, and we got 4x is equal to negative 16. Divide both sides by 4. Then you get x is equal to negative 4. So our answer would be negative 4, 0. Okay, so let's do this on the calculator now. Drop the x's and y's, keep the numbers in their signs. So I got 4, 4, negative 16, negative 6, 6, and 24. Still a 2 by 3. So do second x negative 1. Go over to edit. Enter on A. 2 inner, 3 inner. Got 4 inner, 4 inner. Negative 16 inner. Negative 6 inner. 6 inner. 24 inner. Exit out, so do second mode. Go back in my matrix menu. Go over to math. Up arrow to REF. Enter. Go back in the matrix menu. Do enter on A. Enter again. Okay, we end up with 1, negative 1, negative 4, 0, 1, 0. Except for I did REF. Okay, I didn't mean to do that. I was wondering, those results looked a little weird. Didn't look like one of our oddball cases, and it sure didn't look like our answer. So, okay, I'll try it again. Second, x negative 1. Go to math. Go to REF, the one with 2 R's. And then I'll go back in the matrix menu. Do enter on A, enter again. So I got 1, 0, 0, 1, negative 4, 0. That looks better. Again, 2 equations, 2 variables. Your first 2 by 2 should be a diagonal 1, zeros over else. That means it worked. This is x, and this is y. And so we end up with, again, the answer negative 4, 0. Number 15. I want to solve this by the addition method. So we got 4x plus 2y is equal to negative 20. 10x plus 5y is equal to negative 50. I want to eliminate one of the variables. I'll choose the y's this time. So I'll multiply the first equation by negative 5 and the second equation by 2. They have to be different signs. So since these are both positive, one of these had to be negative. Negative 5 times 4x is negative 20x. Negative 5 times 2y is negative 10y. Negative 5 times negative 20 is 100. And I'll multiply the second equation by 2. 2 times 10x is 20x. 2 times 5y is 10y. 2 times negative 50 is negative 100. Add these together. Negative 20x plus 20x drops away. Negative 10y plus 10y drops away, gives us 0. 100 minus 100 is 0. So we end up with 0 is equal to 0. Well, this is one of our oddball cases. When you get 0 is equal to 0, that means that's always true, which always true means you got infinite solutions, which means they're dependent. Now let's do this on the calculator. Again, put the numbers, drop the variables in their, drop the variables in equals. So I got 4, 2, negative 20, 10, 5, negative 50. So go in the matrix menu and do second x negative 1. Go over to edit, do enter on A. 2 by 3, so I do 2 inner, 3 inner. And I got 4 inner, 2 inner, negative 20 inner. Then 10 inner, 5 inner, and negative 50 inner. Exit out, do second mode, go back in matrix menu, second x to negative 1, right arrow to math, up arrow to RAF, press enter on it, go back in matrix menu, do enter on A, enter again. We get decimals, we don't want decimals at all, so we do math, enter, enter. And we get it 1, 1/2, negative 5, 0, 0, 0. Well, first 2 by 2 is not a diagonal is 1 zeros everywhere else, which means it failed. Last row is all zeros, which means infinite solutions or dependent. So that gives us our same answer. Let's see, number 16. Let me start a new page. Probably have enough room, but so we got y equals negative 5x plus 9, and we've got negative 8x plus y equals 9. Well, it tells us to use the addition method. And addition method works best. Yeah, addition method. Addition method works best if you have all the terms of variables on one side, numbers on the other. So let's take this negative 5x and move it over. As I move it over, I want to make sure I line the x's up and the y's up. So we're going to have 5x plus y is equal to 9, and negative 8x plus y is equal to 9. Well, I want to eliminate one of the variables. Probably y is the easiest. So I'll multiply this second equation by negative 1. So we're going to have 5x plus y is equal to 9. Negative 1 times negative 8x is a positive 8x. Negative 1 times y is negative y. Negative 1 times 9 is negative 9. Add them. 5x plus 8x is 13x. Y minus y drops away. 9 minus 9 is 0. So then I'm going to solve for x. So I divide both sides by 13. And we get x is equal to 0. Now I want to plug that into one of my equations and solve for the other variable. Probably the first equation is the easiest. So I got y is equal to negative 5x plus 9. And we just said x is 0. So I'm going to have negative 5 times 0 plus 9. Negative 5 times 0 drops away, so we get y is equal to 9. So our answer would be 0, 9. Now to plug this in your calculator, you want to choose the system equations where all the variables are on one side and numbers on the other side. Okay, so we'll write down a matrix goes along with that. We got 5, 1, 9, negative 8, 1, 9. It's a 2 by 3. Okay, so I'm going to do second x negative 1, go to matrix menu, go over to edit, enter on A, 2 by 3. I got 5, 1, 9, and negative 8, 1, and 9. Exit out, second mode. And by the way, instead of going to the matrix menu at this point, if you do second enter, it'll go back to your previous entry. If you do second enter again, you'll find RAF. And we get 1, 0, 0, 1, and 0, 9. Now we're working with two equations, two variables. So our first 2 by 2 should be a diagonal ones, zeros over else, which it is. That means it worked. So this will be x, and this will be y. And, well, I already wrote the answer down, but 0, 9 would be our answer. Okay, number 17. Solved by addition. So we got y is equal to 4x plus 12. And we got 2y equals 8x plus 14. Technically, you do not have to have all the variable terms on one side. You just have to have the like terms lined up. Y's are lined up, x's are lined up, and the numbers lined up. I'm going to leave it in this form just to demonstrate that. This one, everything was not lined up to begin with. You know, of course, your equals has to be lined up too. Well, I want to eliminate, what do I want to eliminate? The x's, I guess. So I'll multiply this first one by negative 2. So negative 2 times y is negative 2y. Negative 2 times 4x is negative 8x. Negative 2 times 12 is negative 24. Then the second equation just carries along. And now I'm ready to add them together. Okay. Negative 2y plus 2y is 0. Drops away. Negative 8x plus 8x is 0. Negative 24 plus 14 is negative 10. So we end up with 0 is equal to negative 10. Well, I got a problem. Our variables disappeared again. When is 0 equal to negative 10? Never. That's our no solution. Or the term that they're asking specifically for is inconsistent. Okay, now to do this on the calculator, you do have to have all the variable terms on one side. So in the calculator, I would take the 4x, move it over, and I'd take the 8x and move it over. So we're going to have negative 4x plus y is equal to 12. And we'll have negative 8x plus 2y is equal to 14. Notice as I moved them over, they lined up the x's, I lined up the y's, and lined up the numbers. So we're going to have negative 4, 1, 12, negative 8, 2, and 14. Let's go and put this in. So do second x negative 1, go over to edit, enter on A. So 2 by 3, so I do 2 enter, 3 enter. And we got negative 4, enter, 1, enter, 12, enter, negative 8, enter, 2, enter, 14, enter. Exit out, do second mode, and I'm going to do it the long way to get RAF, not the shortcut way I just showed on the last problem, but second x negative 1. It's always a good idea to know where it is. Right arrow to math, up arrow to RAF. What if you lose it in your history? Do enter on that. Go back in your matrix menu. Enter on A, enter again. We get a decimal, we don't want decimals. Do math, enter, enter. Okay, so we end up with 1, negative 1/4, 0, 0, 0, 1. Well, first off, the first 2 by 2 should be a diagonal 1, 0 over else. It isn't. It means it failed. And last row is all zeros and a single 1, which means no solution or inconsistent. That gives us the same result. Number 18. Solve the following system by addition. 6x plus 3y equals 24. And 6x plus 2y equals 30. Notice that the numbers in front of the x's are the same. Something's going to happen with that. Okay, I'm going to multiply the second equation by negative 1. Doesn't matter which one. I'm going to eliminate the x's. So I got 6x plus 3y equals 24. Negative 1 times 6x is negative 6x. Negative 1 times 2y is negative 2y. And negative 1 times 30 is negative 30. 6x minus 6x drops away. 3y minus 2y is y. And 24 minus 30 is negative 6. Now notice on this, when they're the same like that, it works out really nice how they cancel. You could almost not even multiply it. You could just subtract them. 6x minus 6x drops away. 3y minus 2y is y. 24 minus 30 is negative 6. So when they're already the same number, it works out really nice. Okay. Now I'm going to plug this into one of my equations. Doesn't matter which one. Plug in the first one. So I got 6x plus 3y is equal to 24. We just said y is negative 6. So we got 6x plus 3 times negative 6 equals 24. 3 times negative 6 is negative 18. Take the negative 18 over, it becomes a positive 18. Which gives us 2, 3, 42, I believe. Divide both sides by 6. And we get x is equal to 7. So our answer would be 7, negative 6. You have to make sure you put the x first and the y second. Sometimes I'm bad about that. And I don't catch myself doing that. This time I did, but not always. Okay. Let's do it on the calculator now. So I have my matrix. Drop the x's, drop the y's and equals. Keep the numbers in their signs. Size of this matrix, rows by columns, is 2 by 3. So I'm going to go ahead and put it in. I do second x negative 1. Go over to edit, enter on A, 2 enter, 3 enter. I got 6, 3, 24. And I got 6, 2, and 30. Exit out, second mode. Go back in matrix menu, second x negative 1. Go over to math, up arrow to RREF, enter. Go back in my matrix menu, enter on A, enter again. So I got 1, 0, 0, 1, 7, negative 6. Our first 2 by 2 is a diagonal 1, 0, 0, well, so it worked. So this is our answer. This will be x, and this will be y. And that gives us our 7, negative 6 we already found. Let me save this. And let's look at number 19. Let me grab a drink. Then we'll get into the word problems. That's where the real headache will start. 3/2 x plus 2y is equal to 4. And 1/5 x plus 1/5 y is equal to 1. Okay, first off, it wants us to solve by addition. We never want to work with fractions, so let's get rid of the fractions. I'm going to multiply everything in the first equation by 2 to get rid of the fraction, the LCM of all your denominators. And I'll multiply everything in the second equation by 5, the LCM of all your denominators. Now 2 times 3/2 x gives us 3x. 2 times 2 gives us 4y. And 2 times 4 gives us 8. Now here 5 times 1/5 is 1, so that's 1x or x. Plus 5 times 1/5 is 1, or 1y or y. And 5 times 1 is 5. Now it's much easier to work with. I'm going to eliminate the y's, I guess. So multiply the second equation by negative 4. So we got 3x plus 4y is equal to 8. Negative 4 times x is negative 4x. Negative 4 times y is negative 4y. And negative 4 times 5 is negative 20. 3x minus 4x is negative 1x or negative x. 4y minus 4y drops away. 8 minus 20 is negative 12. Divide both sides by a number in front of your x, which is negative 1. And we get x is equal to 12. Now I want to plug that back into one of my equations and solve for the other variable. Now I'll choose this one, x plus y is equal to 5. Now it doesn't have to be the original. Those would be nasty to go back to. Okay, so we just said the x is 12, so we've got 12 plus y is equal to 5. Take the 12 over, we get 5 minus 12, which gives us negative 7. So our answer will be 12, negative 7. Now on the calculator. Calculator doesn't care that we have fractions, so we'll have 3 halves, 2, and 4, and we'll have 1/5, 1/5, and 1. Still a 2 by 3. So we'll go ahead and put that in. I'm going to do second x to negative 1. Go over to edit, enter on A. It's a 2 by 3, so I do 2 enter, 3 enter. And I got 3 halves, so I got 3 divided by 2. 2 and 4. Then 1/5, so 1 divided by 5. 1 divided by 5. And 1. And then I'll exit out, so I'll do second mode. Now I'm going to do REF, so do second x to negative 1, right arrow to math, up arrow to REF, press enter, go back in the matrix menu, do enter on A, enter again. And we get 12, negative 7. Our first 2 by 2 is a diagonal 1, there's everywhere else, means it worked. It means this is x and this is y, and matches what we came up with here. Okay, now the word problems. Now you probably see me struggle a little bit on these. Word problems are just challenging. I could have these all worked out ahead of time and have them reading off a piece of paper. But I think it's important for you to realize that everybody struggles with word problems. There's just some word problems you'll run across that one day you'll read them and it'll go just fine. The next day you'll read it and you'll just read it incorrectly and think the setup wrong. Okay, difference between two numbers is 34. So it looks like we've got two numbers. So x is our first number and y is going to be our second number. Okay, difference between the two numbers is 34. Difference means we subtract, and we have to identify which one's our larger one then. So I'll say x is larger. It doesn't matter which one you specify. If that's a larger one, then y must be a smaller one. Okay, difference between them is 34. So they're saying that x minus y is equal to 34. I had to arrange it in this manner because the larger one has to go first if the difference is going to be positive. Now if it said a difference is negative, then I would have want to flip these around. Okay, 3 times is smaller. Smaller. 3 times is smaller. Smaller is y, so 3y is, there's our equals, or is equal to, that's our equals, 8 more than larger. 8 more than larger. 3 is 8 more than larger. So this would be x plus 8. Sometimes this is plus 8, sometimes it's minus 8. We'll know when we go through and work this, if we come up with bizarre results and we know the setup is wrong, I need to put a minus here. And I'm not saying that I won't mess some of these up. I'm going to use the addition method because I like that best. I think you've seen the calculator. I won't show that. So I want to get all the variables on one side, so I'll take the x, move it over. So we've got negative x plus 3y is equal to 8. Negative x plus x drops away. Negative y plus 3y is 2y. 34 plus 8 is 42. Divide both sides by 2. And we get y is equal to 21. Okay. That kind of gives me warning. Oh no, I guess that could still be valid. Okay, let's see. Then I want to find out what x is. So I'll plug that into one of my equations. So I got x minus 21 equals 34. So I'll plug the 21 in for the y here. Then take the 21 over, and we get x is equal to 55. Let's see if that fits with our what we've said. Difference between two numbers is 34. 55 minus 21 is 34. That works. 3 times the smaller. 3 times the smaller. 3 times that is 63. Okay. Is 8 more than larger? 8 more than larger. 55 plus 8 would be 63. Okay, so it checks. So those would be our two numbers. 21. We got Jane travels 6 times faster than Brenda. Traveling in opposite directions, they are 210 miles apart after 2 hours. Find the rates of travel. Okay. They're traveling in opposite directions. They are 210 miles apart after 2 hours. I know how to set this up normally, but how do you set it up with system equations? Travels 6 times faster than Brenda. So Jane and Brenda. First start off with that. Now one of these is being put in reference to the other, so it looks like all of these are talking about rates of travel, aren't they? So R. Okay, so Jane, and we're going to have R here. Now instead of R, let me choose X. And this will be Y. Keep in mind though, what we're dealing with here is these are R's. Okay, so then Jane travels 6 times faster than Brenda. So Jane is faster. So we'll say let's see if that Jane travels 6 times faster than Brenda. Jane is this. Okay, I wrote that wrong. X would equal to 6y. The reason why, it says that Jane travels 6 times faster than Brenda. If Brenda is going 10 miles per hour, then Jane would be 6 times 10 or 60 miles per hour. So Jane's faster. Okay, so that's the equation they've given us. Traveling in opposite directions, they're 210 miles apart after 2 hours. Traveling in opposite directions. So here's J and B. They start in the same location, and they're going in opposite directions. So they're working together to achieve this distance. So distance is equal to R times T. So the rate and time of Jane plus the rate and time, or rate times time of Brenda, is going to give us our total distance. Well, time, 2 hours. So they're telling us 2 hours. So, and rate of Jane is X. Remember, this is our R. So this is X times 2, or 2X, plus, and this T is 2, and rate of Brenda is Y, so we're going to have 2Y, equals our total distance, which is 210. Probably the easiest. Here's our first equation. here's our second equation. Probably the easiest one here is the substitution. So I'll plug the x equals 6y. I'll put 6y in for the x. So I got 2 times 6y plus 2y is equal to 210. 2 times 6 gives us 12y plus 2y is equal to 210. That gives us 14y is equal to 210. Divide both sides by 14. Let's see, that gives us 15, which Brenda would then be 15 miles per hour. What are they doing? Driving? Travels. Okay, doesn't say if they're in a car or what. It's pretty slow for a car. Then Jane is 6 times that. So 6 times y. So 6 times 15 gives us 90. She's really traveling fast. She's driving 90 miles per hour in a car, and Brenda's going so slow it's not even... Okay. Okay, regardless. Let's see if those make sense. Besides the fact that you shouldn't be going 90 miles per hour. Okay. 6 times, so that fits. And together, they want to achieve that total distance. If I put 90 here, 2 times 90 is 180. 2 times 15 is 30. 180 plus 30 is 210. So those check. So those would be our answers. Okay, let me save that. 90 miles per hour. Do not try this at home. And ready for number 22. Let me grab a drink here. Okay, money one. It looks like we got nickels and dimes. So I'm assuming the count is what we're talking about. How many of each type? So we're talking about count. So the number of nickels, and y will be the number of dimes. It doesn't matter which one is which. If I flip those around and said this is the number of dimes, this is the number of nickels, it still works out the same, as weird as that seems. Okay, $6 worth of change in nickels and dimes. Well, that means my nickels plus my dimes gives me $6. Well, nickels is worth 5 cents, so that'll be 0.05x. Dimes are worth 10 cents, so that's 0.10y equals $6. First off, I hate decimals, so I'll move these 2 decimal places to the right. So that'll be 5x plus 10y is equal to 600. And I can divide all these by 5 to make my number a little smaller. 5 divided by 5 is 1, so that's x, plus 10 divided by 5 is 2y, and 60 divided by 5 is, what is it? 120? Yeah, 120. Okay, so that's our first equation we're working with. Let's look for our second equation. If she has 4 times as many nickels as dimes, 4 times as many nickels, so we've got more nickels. So nickels, which is x, is going to equal 4y. Let's think about that. 4 times as many nickels as dimes. If it has 10 dimes, then 4 times that is 40 nickels. So that makes sense for the setup. So that's our second equation. Probably the substitution method's the easiest here. I'm going to plug x equals 4y. I replace the x here with 4y. So we've got 4y plus 2y is equal to 120. 4y plus 2y is 6y equals 120. Divide both sides by 6, and you get y is equal to 20. Okay. Then we got this equation, x equals 4y. So I'll put 20 in for the y. 4 times 20 is 80. So I'll have 80 nickels. Now let's think about the problem. 4 times as many nickels as dimes. 4 times as many nickels as dimes. 4 times 20 is 80. That works. And if I plug it into here, I'll pick this equation. We got 5 times 80 is 400. 10 times 20 is 200. 400 plus 200 is 600, so that checks. Excuse me. 23. Never ending. The length of a rectangle is 4 feet less than 4 times the width. If the perimeter is 182 feet, find the length and width of the rectangle. Well, I could go with x's and y's again. So I'll say x is my length and y is my width. Now remember, we're given an equation for perimeter. I was looking to see if they either give you perimeter or area. Since area is dealing with multiplication, usually these are perimeter. Perimeter is equal to 2 times the length plus 2 times the width. Well, perimeter, they tell us, is 182. 2 times the length, and length was x, plus 2 times the width, and width is y. Now I notice that I can divide all these by 2 to make them numbers a little smaller. So 182 divided by 2 gives me 91. 2 divided by 2 is 1, so that gives me x, plus 2 divided by 2 is 1, so that gives me y. So this is going to be our first equation we'll work with. Our second equation. The length of a rectangle is 4 feet less than 4 times the width. Length of a rectangle. Length of a rectangle we said was x. That's our equals, 4 feet less than 4 times width. 4 times width be 4 times the width, which was y. Here's the hard part. 4 feet less. 4 feet less. I think this should be a minus 4. Sometimes it's a plus 4, and I just don't see it. Okay, that's our second equation. Well, let's take our second equation and plug it into our first one. So where the x is here, we're going to replace it 4y plus 4. 4y minus 4. So we've got 91 is equal to 4y minus 4 plus y. 4y plus y is 5y. Take negative 4 over. We got 91 plus 4 equals 5y. Which gives us 95 is equal to 5y. Divide both sides by 5. And we get y is equal to 19. And so then, if I plug this back into one of my other equations, this one I'll choose. So we got x is equal to 4y minus 4. So we got 4 times 19 minus 4, which gives us 76 minus 4, which gives us 72. Let me double check my math there. Yeah. So this one would be 72. Let's see if this makes sense. Perimeter is 182. Okay, if I double that, that gives me 144. If I double this, that gives me 38. If I add those together, that gives me 182. Okay, so that checks. Now, the length of a rectangle is 4 feet less than 4 times the width. 4 times the width. 4 times 19 is something. 6, 3, 76. It's 4 feet less than 4 times width. 4 feet less. Yeah, that works. So those would be your answers. So far I've had pretty good luck. Usually there's one or two that I struggle with, but maybe today will be a lucky day. Number 24. Admission to a baseball game is $3.50 for general admission, $6 reserved. The receipts were $3,975.50 for 903 paid admissions. How many each ticket were sold? Okay, general reserved. So general, say, is X, and reserved is going to equal to Y. And they told us there was 923. Let me make sure there's nothing else to the right. Oh, no, there isn't. So 923, which means they're telling us that x plus y is equal to 923. Because this is the count of how many there are. So that's our first equation. Okay, admission is 350 for general. So we got 350 times general. So 350 times the number of general tickets. My wife's got that little beeper going off in the background. $6 for reserved. So $6 times y gives me my total, $39.75 and 50 cents. Well, I hate decimals. So if I move these all one decimal place, I can get rid of them. So that'd be 35x plus 60y equals 39755. These are all divisible by 5, so I can make it a little bit simpler. That gives me 7x plus 12y equals, pushing my luck if I try to do that one, 39,755 divided by 5. 79.51. Okay, and that's our second equation. Well, probably the addition method might not be too bad. So I'm going to have 7x plus 12y is equal to 79.51. And our second equation, x plus y is equal to 923. Now I'm going to eliminate one of the variables, and I'll choose the y's. So I'll multiply the second equation by negative 12. So I got 7x plus 12y is equal to 7,951. Negative 12 times x is negative 12x. Negative 12 times y is negative 12y. And negative 12 times 923 gives us negative 11,076. And I'm going to add these now. 7x minus 12x is negative 5x. Negative 12y plus 12y cancels. That plus 79.51 gives us negative 3,125. Divide both sides by negative 5. Then we get 625. And that would be the number of general admissions. Now they add up to 923. So if I take 923 minus 625, gives us 298. Assuming no basic math errors, I won't double check that, but if you plug that in for x and y here, it should give you that total. Let me save that page and we'll look at the next one. How long have I been doing this? Since 8:52. It's about an hour and a half, hour and 40 minutes. Ah! Okay. Now let's take a look at number 25. Joan has some dimes and quarters. I can see the last problem. Okay, so we got dimes and quarters. And I got 19 coins total. So x is going to be the number of dimes. And y will be the number of quarters. In total, we have 19 coins, so they're telling us that x plus y is equal to 19. So that's our first equation. And then simply tells us they're worth 235. 235. So dimes are worth 10 cents, so that'll be 0.10x plus quarters are worth 25 cents. So 0.25y is equal to 235. I hate decimals, so I'll get rid of them. I'll move these two decimal places to the right. So we've got 10x plus 25y is equal to 235. Those are all divisible by 5, so I can make them a little bit easier. 10 divided by 5 is 2x, plus 25 divided by 5 is 5y. 235 divided by 5 is 47. Yeah. Okay, now we got this equation and this equation. So I got 2x plus 5y is equal to 47. And x plus y is equal to 19. I'm going to use the addition method. I'm going to eliminate the y's. So I'm lying. I'm going to eliminate the x's. I'll multiply the second equation by negative 2. So we got 2x plus 5y is equal to 47. Negative 2 times x is negative 2x. Negative 2 times y is negative 2y. Negative 2 times 39 is negative 38. 2x minus 2x drops away. 5y minus 2y is 3y. Subtract those and I get 9. So it gives us y is equal to 3. Now the total coins is 19, so if there's 3 quarters, that means there's 16 dimes. Okay, 16 dimes is $1.60, and this is 75 cents, so $1.60 and 75 cents. Let's see, 12, 13, 235. Yeah, that checks. Grab a drink here. Okay, number 26. 2,637 is invested, part of 13%, and rest at 11%. How much is invested each rate? So it looks like we're talking about the amount. So we got 13% and 11%. So 13% amount is going to be X, and 11% amount is going to be Y. Now it tells us that 2,637 is invested, which means that the amount invested at this plus this is going to give us that total. So X plus Y is equal to 2637. That's our first equation. Okay, interest earned. Interest is principal times rate times time, and we're talking about, doesn't say anything about the year, but we assume the year is 1, so we can ignore the year. So principal is equal to rate times time. Okay, so principal, what am I saying? I is equal to PRT. So our interest is principal times the rate. And these are the amount we're putting into the account, and time we said is 1. So we're basically dealing with I is equal to PR. Okay, so we're going to have this amount times this rate. So we got 0.13x plus this amount times this rate, 0.11y, is going to give us our total interest. Because they're working together to achieve the interest. It helps to actually read the problem. Try it again. This is going to be a problem I'm going to mess up on, I guess. Okay. If the interest earned from the amount invested at 13% exceeds the interest earned from the amount invested at 11% by this amount. So 0.13x, maybe. Yeah, 0.13x exceeds the interest earned from the income invested at 11%. 0.11y by 6561. Okay, so this amount at 13% exceeds this amount by this much. And that's our interest they're talking about, which is why I did P times R. P is the amount you put in an account times your R. Well, let's get rid of those decimals. So this becomes 13x equals 11y plus 6561. I moved all of them 2 decimal places to the right. And trying to think which would be the easiest method. I'm going to use the addition method just because I like it better. So I got x plus y is equal to 2637. Here I'll take that 11y over, so we got 13x minus 11y equals 6561. I'm going to eliminate the y's, so I'll multiply the first equation by 11. So I got 11x plus 11y equals 2637 times 11, 29,007. This is 13x minus 11y equals 6561. So I add those, and that gives us 24x. 11y minus 11y cancels. 6, 5, 5, 1. Okay, and divide both sides by 24. So 35,568 divided by 24. 1482. Okay, now adds up to 2637. So if I take 2637 minus 1482, hmm. 2637 minus 1482. 1155. Okay, so this is the amount of 13% will be 1482. Amount of this will be 1155. Maybe. Let me double check that. Question is whether it works in here. So 0.13 times x, so 0.13 times 1482 gives us that 192.66. And then 0.11y plus that, so I got 0.11 times y, which we said y was 1155, plus 6561. It gives us the same value. So it checks, assuming that my interpretation of the wording is correct. That's always an assumption you have to go with here, that how I read that is correct. Just because I worked the problem right doesn't mean squat, really, if I didn't read the wording right. Okay, number 27. Let's see, it looks like a mixture problem. How many pounds? So, okay, we're talking about pounds. So we got 49% and 62%. So X is going to be our amount at 49%. And Y is going to be our amount at 62%. They say how many pounds of each must be to make 51 pounds of a third alloy. So we want 51 total. Which they're telling us then that X plus Y is equal to 51. Okay, now our mixture is such that the 49% times X plus 62% times Y is going to give us our new, which is 56%, times our total, which is 51. Now how these always work is you have your percent times amount, percent times amount, percent times amount. So see how it went across the board like that? Okay, well, this is, give her the decimals. I got 49x plus 62y equals 56 times 51. So I'm going to have 49x plus 62y equals 56 times 51, 2856. I guess I'll use substitution on this. That might be the easiest. On this one, I'll solve for y. So I'll take the x over. So you got y is equal to 51 minus x. Now I'm going to replace the y here with 51 minus x. So I got 49x plus 62 times 51 minus x equals 2856. Distributive property, 62 times 51. So 62 times 51, 3162, minus 62x equals 2856. Combined together like terms, 49x minus 62x is negative 13x. Take 3162 to the right side, so we got 2856 minus 3162. So 2856 minus 3162 gives us negative 306. Divide both sides by negative 13. That doesn't look good. Okay, let me double check the problem. 49, 62%. 49, 62%. X is that. Okay. How many pounds of each alloy must you use to make 51 pounds of a third alloy? Okay, so X plus Y is equal to 51. That looks good. And then we got 0.49 times X plus 6.62 times Y equals third alloy containing 50. Oh, round off answers nearest hundredth. Okay, so we got 23.54. It's kind of an indication right there when they give you those instructions, you can come up with decimals. Everything else, we've had no decimals this section, so I assumed this one would be no decimals. So 23.54. Okay, now y is equal to 51 minus x. So we got 51 minus 23.54. So 51 minus 23.54. 2746. I was wondering, because usually mixture ones are the easiest ones. So those would be your answers. I won't check it, because like I say, the mixture ones are always the simpler ones, in my opinion. 28. Total of 9,000 invested, part 6%, remainder at 10%. Okay, so we got 6% and 10%. So X is going to be the amount at 6%, and Y is going to be the amount at 10%. And they're telling us that there's a total of 9,000. So they're telling us that X plus Y is equal to 9,000. Okay, annual interest is 790. Okay, so they're telling us that 0.06x plus 0.10y is equal to, how much was interest? 790. No memory. Well, I'm going to give her these decimals, so I move the two decimal places to the right. So we got 6x plus 10y is equal to 790 with two zeros. Everything's divisible by 2. That makes it a little smaller. So we got 3x plus 5y equals 38,500. 6. Let me check it. 79,000 divided by 2. Yeah, 39,500. Good thing I checked it. Okay, so we have this equation and this equation. So I got 3x plus 5y is equal to 39,500. And x plus y is equal to 9,000. I'm going to use the addition method. So I'll multiply, I'll get rid of the y. So I'll multiply this second equation by negative 5. So we'll have 3x plus 5y is equal to 39,500. Negative 5 times x is negative 5x. Negative 5 times y is negative 5y. Negative 5 times 9,000 is negative 45,000. 3x minus 5x is negative 2x. 5y minus 5y drops away. 39,500 minus 45,000. So it'll give us negative 5,500. Divide by negative 2. Try and get x by itself, and we get 2750. Okay, so that's going to be the amount at 6%. Now total is 9,000, so I take 9,000 minus 2750. $62.50. And that would be our answers. Let me start a new page. Number 29. How many liters each of okay, looks like a mixture problem. So we got 10% and 35%. So x is the amount at 10%. Y is the amount at 35%. Let's see. Liter less. Okay. Produce 40 liters. So it looks like together they add up to 40. So x plus y is equal to 40. And mixture again is a lot easier. You take your percent times your amount plus percent times your amount equals the final percent, which they tell us is 30%, times amount, which they tell us is 40 liters. Okay, move this 2 decimal places to the right, so we got 10x plus 35y equals 30 times 40. Notice I only move it in one place here. So we got 10x plus 35y equals 1200. They're all divisible by 5. That makes them a little smaller. 10 divided by 5 is 2, so we got 2x plus 7y equals 240. Yeah, 240. And we got this. So probably an addition method. So we got 2x plus 7y is equal to 240. And we got x plus y is equal to 40. I'll get rid of the x, I guess. So I'll multiply this by negative 2. So we got 2x plus 7y is equal to 240. Negative 2 times x is negative 2x. Negative 2 times y is negative 2y. Negative 2 times 40 is negative 80. 2x minus 2x drops away. 7y minus 2y is 5y. 240 minus 80 is 160. Divide both sides by 5, and we get 32. So it'd be 32, and add up to 40, so it'd be 8. Okay, put 8 here, that's 80. Plus 35 times 32. Okay, that checks. So those are our answers. Number 30. Investment. Okay, so we got 5% and 10%. We're talking about the amount. Looks like how much is invested. Yeah. So X will be the amount at 5%. And Y is going to be our amount at the 10%. Doesn't say anything about how much is invested, so okay. Jarvis also invested 152 more than 3 times the amount at 10%. Jarvis. So 3 times the amount at 10%. Let's start with that. So 10% is Y, so that'd be 3Y. Has invested 152 more than 3 times the amount. Has invested 300 more than 3 times the amount. Not sure if I'm reading this right. Doesn't really say. I'm assuming that Jarvis is referring to the 5%. Oh, here. Jarvis invested some money at 5%. Also invested. Again, I'm assuming it's referring to the 5%. 3 times that amount. 152 more. Let's try 152. It might need to be a minus 152. We'll see. Okay, now total interest they told us I saw was this. So that means that 0.05x plus 0.10y is going to equal to 1387.90. Okay, so I'm getting kind of tired of working these addition and substitution, so let me use calculator on this one. I'll take this x over here, and we got negative x plus 3y is equal to 152. Our matrix would be 0.05, 0.10, 1387.90, and negative 1, 3, and 152. Okay. So do second x negative 1, go over to edit, enter on A, still 2 by 3. So I got 0.05, 0.10. You don't actually need zeros at the end. 1387.90. Negative 1, 3, and 152. Exit out. Go back on my matrix menu. Right arrow math, up arrow to REF. Enter. Go back on my matrix menu. Enter on A, enter again. And we get 16,594 and 5,582. This will be our x, and this will be our y. And it worked because I got my diagonal 1 zeros everywhere else. So this is 16,594, 5,582. I feel good that there's no decimals here. Yeah, that says round 2 decimal places if necessary. Okay, I don't feel as good now. Let's see. Well, I don't need to check it. The idea is if I read it right. 152 more than 3 times the amount. So 3 times that and 152 more. I'm pretty sure I interpret that correctly. Part of part of the hard problem on word problems is actually reading it and understanding exactly what are they trying to tell you, not actually solving the problem. In real life, you would go back to the person and say, what do you mean by this exactly? So, people get stressed out, well, I'll never learn word problems. How am I going to be able to do whatever function in whatever occupation I'm going into? Well, it's communication. You go there and say, do you mean this? And then you say, yeah, that's what I meant. And then you could use technology to find your answer. And, of course, in real life, nobody would sit there and do this by hand. But anyway, that's the review.